Open your books to 727. We are going to be talking about area of parallelograms today. That is chapter 9, lesson 6. And as I've kind of alluded to already today, and if you've been practicing your vocabulary cards, you'll know there's a lot of different vocabulary words that we need to understand involving four-sided figures. Now, I've went ahead and turned on the answers for this particular diagram, and parallelograms, as it says in this little paragraph, the only thing you have to be a parallelogram is it has to be two sides. The opposite sides have to be parallel, hence the word parallelogram. So this side is parallel to that side. It's called a parallelogram. Okay. Now, I'm going to draw another circle over here because if you have, and this is supposed to be, okay, let's do this a little bit better. So if you have a parallelogram that also has, and I want you to draw this in your book, please, if you have, do a better job than I did. So if you have a parallelogram in which all four angles are right angles, this is called a rectangle. A rectangle is a parallelogram that has all four right angles. Right angles, rectangle. Please remember that. Okay. Now, it's clarifying that a rhombus is a parallelogram. You can see it's kind of a squished up parallelogram, and opposite sides are parallel. But the thing about a rhombus is, and I'm going to draw the congruency signs, all four of the sides are equal. So if you have a parallelogram where all four sides are equal, that's called a rhombus. Now, in a rectangle, all four sides are not equal, but the opposite sides are equal. So the long side is always equivalent to the long side, and the short side is always congruent with the short side. But then we even have a more specific word. If you have a rhombus where all four sides are equal, but you also have all four angles are equal, they're going to be right angles. Okay, 90 plus 90 plus 90 plus 90. And that's the other thing that we need to understand. All four-sided figures, if you add the interior angles, always are equivalent to 360 degrees. 90 plus 90 plus 90 plus 90, or 90 times 4 is 360. So triangles always have interior angles that are equivalent to 180. Rectangles always have equivalent to 360. This is something we just have to memorize when we're talking about geometry. Which brings us back to our friend the rectangle. Well, if we have all four angles are right angles, that sounds familiar. That's the definition of rectangle. So a square is a rectangle that has all four sides equal. A square is a rhombus because all four sides are equal. A rhombus is not always a rectangle because it does not have all four sides being 90 degrees necessarily. And if it did have all four sides being 90 degrees, we would call it a square. So make sure you'd make some notes on this because you have to understand all of this craziness. Okay, this might look a little scary, but really, finding the area of parallelograms is identical to finding the area of rectangles if you understand one thing. The area of a parallelogram is going to be base times height. And you're like, wait, but rectangles are length times width. But here's the deal. So we have our squishy little parallelogram. If we were to cut off this little triangle that sticks out, and we were to move it to the other side like a puzzle piece, and I'm going to get my little pen here. So here's the original, I'm going to change my, okay, so here's the original parallelogram. Okay, kind of. And if we were to slice off with a pair of scissors and take this piece and move it over here, we've just created a rectangle, and please pretend those are straight lines. So once we create a rectangle, what was the length times the width, we're going to actually just change that to what they're calling the height. And height is the distance between the top of the figure and the bottom of the figure. And then the bottom side, which we always called the length before, we're going to call that the base. And so really we take the height instead of, now this is the thing we do not need to make this mistake. Never, ever, ever think that this part right here is the height. The height is going to be the distance from the top to the bottom, not the slanty bits. So if you take the height and the base and you treat it like the length and the width, you're going to get the correct area. Okay, the area of a parallelogram is related to the area of a rectangle, as you've discovered in the previous hands-on lab. Well, we didn't actually discover that, but I did talk about the fact that we can cut off this piece, move it over like a puzzle piece, and create a rectangle. So the base of the parallelogram can be any one of its sides, but in comparison to the base, the height has to be perpendicular. So if you decide this is going to be the base, then you would draw a line from the base to the top of the figure, and that's going to be called the height. And it has to create that perpendicular or that right angle, because remember, the right angle is the basis of all rectangles. And so that's why we can make it similar to how we find the area of a rectangle. Okay, parallelograms include special quadrilaterals such as rectangles, squares, and rhombi. All right, let's look at this example here. So we have a parallelogram, and they don't label it, so you have to count the squares. So if you ever run across something you have to find the area for, and they don't tell you how much it is, you have to count it. So this base is 1, 2, 3, 4, 5, 6. So, okay. 1, 2, 3, 4, 5, 6. So if the base is 6, the height 1, 2, 3, 4, 5, 6, 7, 8. So we have the base is 6 times the height of 8, and then that's going to be 48. And the unit is not indicated whether it's inches or feet or miles or whatever. So we're just going to call it units. And we'll use the little square. You could also, if you want to, write square units. This is also something you'll see sometimes. They'll just say the SQ in the front of it. Okay, so there's that. Here's another example, and it actually involves the terrifying decimals. I'm glad, oh no, we're going to look at this for a second, because another way that you'll kind of see them draw height, rather than draw like a line inside the parallelogram, they'll kind of drop down like it's a rectangle. They'll drop down from the top to the bottom. So in this case, the height is 11 7/10. Please do not ever, ever, ever think the height is the slanty part. So if you did 13 times 20 and 8 tenths, you're going to get the wrong answer. So you're going to multiply 11 7/10 times 20 and 8 tenths, and you're not going to panic. You're just going to line it up and do the multiplication, and then you'll find that the area is 243 and 3600 square centimeters. Okay. Now, because we understand the formula, sometimes they're going to ask us to find the missing dimensions. So we do this by using our understanding of algebra. If we know what the product's going to be, if we know the other side of the equation, we can figure out a variable from the opposite side. So to find missing dimensions, you're going to use the formula for the area of a parallelogram to write the equation. You're going to replace the variables with the known measures, and then you'll solve the equation for the remaining variable. All right, so we're going to write and solve the equation to determine the missing dimensions of the parallelogram. So they tell us that the base is 45, they tell us the area is 45 square inches. So everything in the inside is 45 square inches. And we know that the base is 9 inches, but we don't know the height. They leave the height off. So the formula is area is equal to base times height. We know the area is 45. We know the base is 9. So 45 is equal to 9 times h. Well, we do what we know how to do. We divide 9 by 9, and then we're going to divide 45 by 9, and we get 5. And so this is going to be the answer. H is equal to 5 inches, not square inches, because we're talking about just the length of a line here. Okay, we're going to do one of these together. We'll pick the scary fraction one. because, apparently it's scary. First thing we're going to do is set up the problem. Area is equal to base times height. They tell us the area is 108 and 3/8, and that's equal to the base. We do not know the base. This is the base right here. We don't know it. That's the base. But we do know the height, which is the line that's perpendicular to the base, and that is 8 1/2. So if we want to get the base by itself, and it's being multiplied by the height, what are we going to do? What operation are we going to do? That's correct. We're going to divide. So we're going to divide the base times 8 1/2. And whatever we do to one side, we're going to have to do to the other side. All right. So I'm going to go ahead and set this up because in order to divide by a mixed number or a fraction, we're going to have to multiply by the inverse. And as we have learned, this can also be called keep, change, flip. So let me set this up. Okay, the first step is we have to change this mixed number into an improper fraction. 8 times 2 is 16 plus 1 is 17. So we have 17 halves. And so if we are going to keep, change, flip, we keep the 108 and 3/8 the same. We change it to multiplication, and then we're going to multiply by the reciprocal, which is 2 over 17, 2/17. But here we have this problem. What I need you guys to do right now, I know that the denominator will be the same, but we need to change this into an improper fraction as well. So I need everybody to go ahead and calculate. Whoa, hello. Go ahead and calculate 108 times 8 plus 3. So go ahead and solve that for me. Okay, now this is not hard, but it's a lot. Okay, you're going to end up with 867. So it's going to be 867 eighths times 2/17. Now let's hope that we can divide 867 by 17 to simplify this. Go ahead and try that out. All right, for those of you who did that, the answer is 51, so that kind of helps us out a little bit. Now, we can also simplify again before we multiply these two fractions, because I know that 8 is definitely a multiple of 2, so what is 8 divided by 2? Answer that, please. Very good, the answer is 4, so 2 divided by 2 is 1, 8 divided by 2 is 4. So now the final operation we need to do to figure this out, and we're going to actually divide 51 by 4. So go ahead and answer that for me. Remember, we're going to keep this in the form of a fraction and not go to the decimal form because we are working with fractions. So solve that, please. Okay, 4 times 1 is 4, so that's how many times 4 will go into 5. And we're going to get 1 as our answer, bring down the 1, and 12. Excuse me, 2 times 4 is 8. And the reason why we can't, we're going to end up with a fraction is that clearly there's going to be a remainder here. So 11 minus 8 is 3, and the denominator is going to be the divisor. So that's going to be a 4. And so it's going to be 12 and 3/4 will be our answer. 12 and 3/4 meters, just with a meter, not with a square, because what we're talking about is the base, just the length of this side here. All right, so hopefully that did not terrify you. It did involve quite a few steps, but nothing that we can't do. So this time I want you to go ahead and answer that fateful question we do every day. What is the most important thing to remember about this lesson? And please give a good answer. Don't like put all your points in a toilet and flush it and say, I don't know. Or, go back and look at the examples, look at the definitions, look at the things that they brought up today that were important things. Pick one. Go ahead and answer that for me, please. Thank you for your thoughtful answer. Please come to class so we can do more examples together, especially those of you who need help with fractions and decimals, and you may also come to math help as well to get more practice with that. It's up to you to ask me for help. Thank you. Take care.